One more problem on convolution integral. Consider LTA system with the impulse response h of t equals to e to the power of minus t into u of t, and input x of t is equal to e to the power of minus 3t into u of t minus u of t minus 2. Let us find its output. What is y of t? To find the output y of t, let us use the convolution integral formula. Y of t is equal to integral of minus infinity to plus infinity x of tau into h of t minus tau. Integrate with respect to d tau. Here first let us draw the input signal x of t and h of t, where x of t is e to the power of minus 3t into u of t minus of u of t minus 2. Here e to the power of minus 3t is decaying exponential signal. This is t, this is 0, this value is 1. This is the e to the power of minus 3t. Whereas u of t is, its value is 1 from 0 to infinity. Okay. And u of t minus 2 is, it is a shifted version of u of t. It starts at 2 and ends at plus infinity. This is the u of t minus 2. When u of t minus 2 is subtracted from u of t, you will get a signal that is only from 0 to 2. This is the u of t minus of u of t minus 2. When these two signals are multiplied, you will get x of t has only the 0 to 2 multiplication is possible. This is the signal, that is 0, this is 2, this is t, this value is 1. This is the input signal x of t. Similarly, when you draw the impulse response h of t, where h of t is, it looks, that is e to the power of minus t into u of t, signal goes like this. This exists from 0 to infinity. This is the h of t. This is a fixed signal. This is the infinite duration signal. Now we need to convolve the fixed signal, one that is a finite duration signal, and the infinite duration signal. To do this, that is y of t equals to integral of minus infinity to plus infinity e to the power of minus 3 tau, u of tau minus u of t minus tau, it will become 1. H of t is e to the power of, h of t minus tau is e to the power of t minus tau into u of t minus tau into d tau, where this signal is exists only from 0 to 2, where this signal exists from 0 to infinity. That is, from this you can write e to the power of minus t is outside, integral of minus infinity to plus infinity e to the power of minus 3 tau. This is tau, you will get tau is common. Sorry, this is, you can write e to the power of minus 2 tau into u of t minus tau into d tau. First signal exists from 0 to 2, whereas second signal exists from 0 to infinity. To have a non-zero value, second signal should come in the range of first signal. That is, we should see that based on this t value, we should check that whether the second signal should come in the range of first signal. For that, we should consider the three cases here. to fix the range of a signal, that is y of t is, once again I'll write that y of t is equal to integral of minus infinity to plus infinity e to the power of minus t is outside, e to the power of minus 2 tau u of t minus tau into d tau. The minimum value of that's integration limit is 0. Upper limit we need to decide here because the first signal starts from 0. This is the range of the first signal. This is the x of t. Now to decide upper limit, let us take the three cases. Case 1, when t is 0, what happens to this u of t minus tau? That is, you'll get u of minus tau, whereas u of minus tau exists from 0 to minus infinity. Then multiplication is possible at 0. Hence, the y of t is not equal to 0. Next, we'll take that second case when t is less than 0. When t is less than 0, let us take one example. When t is minus 1, you will get u of minus 1 minus tau. This range of this signal is u of, it comes in the range of minus 1 to minus infinity. This is the u of minus 1 minus tau. Hence, multiplication of the second signal with the first signal is not possible because the second signal exists in the range of minus 1 to minus infinity. Hence, the output is y of t is equal to 0 when t is less than 0. Similarly, we will take third case when t is greater than 0. We'll take one example, that is first signal is only 0 to 2. Second signal should come in the range of the first signal, that is the range is 0 to 2. This signal. I'll take one x, that is t is equal to plus 1. Then you will get u of 1 minus tau. That is nothing but u of minus tau plus 1. This signal is, you'll get 1 to minus infinity. This is u of minus tau plus 1. Then multiplication with the first signal is possible only in the range of 0 to 1. When t is 2, you'll get u of 2 minus tau. Then the signal range is, you get u of 2 minus tau is 2 to minus infinity. This is u of 2 minus tau. That means multiplication is possible up to 2. When t is 1, multiplication is possible up to 0 to 1. When t is 2, the multiplication is possible up to 0 to 2. What happens when t is equal to 3? When t is equal to 3, you'll get u of 3 minus tau. The signal range is, you'll get u of 3 minus tau is 3 to minus infinity. Even though the second signal exists from 3 to minus infinity, the multiplication is possible only up to 0 to 2. That means from these three cases, we can conclude that y of t equals to 0 when t is less than 0, and y of t is not equal to 0 when t is greater than or equal to 0. Okay. Again, I'll take here when t is in between 0 to 2, up to the value of t, the multiplication is possible. When t is greater than 2, the maximum limit of the integration is only 2 because first signal exists up to the range of 0 to 2. That means I should take two cases here when t is in between 0 less than or equal to t less than or equal to 2. In that case, the integration limits are 0 to t. That is, y of t is equal to integration e to the power of minus t, integration of 0 to t, e to the power of minus 2 tau, u of t minus tau value is 1, integrate with respect to tau. You'll get y of t is equal to e to the power of minus t. Integration of e to the power of minus 2 tau is e to the power of minus 2 tau divided by minus 2. that is 0 to t, you will get answer is that is e to the power of minus t divided by minus 2. You get e to the power of minus 2t minus 1. Answer is 1 minus e to the power of minus 2t whole divided by 2 into e to the power of minus t. This is the answer when the t is in the range of 0 to 2. Similarly, we'll take the one more condition, that is when t is greater than 2. When t is greater than 2, the multiplication is possible only the up to the 0 to 2, because first signal exists in the range of 0 to 2. And we can write that y of t is equal to integration of 0 to 2 e to the power of minus t is outside, e to the power of minus 2 tau into d tau. That is y of t equals to e to the power of minus t, e to the power of minus 2 tau divided by minus 2. Integration limits are 0 to 2. We'll get e to the power of minus t divided by minus 2. Get e to the power of minus 2, that is you get minus 4 minus e to the power of 0 value is 1. Answer is that is 1 minus e to the power of minus 4 divided by minus plus 2 into e to the power of minus t. That means we have two answers here. There is three answers, that is output signal y of t equals to its value is 0 when t is less than 0, and its value is 1 minus e to the power of minus 2t divided by 2 into e to the power of minus t when t is in between 0 to 2, and its value is 1 minus e to the power of minus 4 divided by 2 into e to the power of minus t when t is greater than 2. To draw its output signal, that is it looks like this. This is t, this is 0, this is the y of t. When t is in between 0 to 2, should use this output. When t is greater than 2, should use this output. And we draw this, it goes like this. Maximum value of t, that is when t is 2, you'll get this answer, that is next it goes on decaying.